Question 1. In the context of energy auditing, Mr. Patel is reviewing a commercial building with variable air volume (VAV) systems showing inconsistent zone temperatures and high energy consumption. He suspects improper duct sealing and air leakage are primary causes. What should Mr. Patel prioritize during his diagnostic testing to accurately assess the system's efficiency loss? A. Measure refrigerant charge and superheat values. B. Conduct duct leakage testing and static pressure measurements. C. Evaluate thermostat calibration and control sequencing. D. Record building envelope surface temperatures with thermal imaging. Answer. Correct answer. B. Explanation. Duct leakage testing and static pressure measurements are crucial in diagnosing energy loss in VAV systems due to improper duct sealing. Leakage leads to pressure imbalances and uneven airflow, causing temperature inconsistencies and energy waste. Refrigerant charge A and thermostat calibration C affect other system aspects but not directly duct-related losses. Thermal imaging D assists in building envelope analysis but cannot pinpoint duct leakage. Prioritizing duct leakage tests aligns with ASHRAE and HVAC guidelines to ensure proper air distribution efficiency. Question 2. Given the circumstances that Ms. Rodriguez is auditing, a residential heat pump system installed 5 years ago, she notices that the coefficient of performance, COP, is significantly lower than expected despite no visible mechanical faults. What conceptual factor should Ms. Rodriguez consider as a likely contributor to reduced system efficiency? A. Incorrect refrigerant charge causing poor vapor compression cycle performance. B. Excessive building envelope insulation reducing system load. C. An oversized heat pump causing frequent short cycling. D. Improper ductwork insulation increasing heat loss. Answer. Correct answer. A. Explanation. Incorrect refrigerant charge disrupts the vapor compression cycle, lowering COP by reducing heat transfer efficiency. Though oversized systems C cause inefficiency, they typically increase energy consumption through short cycling, not reduced COP directly. Excessive insulation B lowers load and often improves efficiency. Improper duct insulation D affects distribution but less critically impacts COP at the level. Understanding the vapor compression cycle is key for diagnosing heat pump inefficiencies. Question 3. Considering the evidence from a recent audit by Mr. Kim of an office building, he notes poor indoor air quality (IAQ) complaints despite the ventilation system meeting airflow design specifications. What underlying cause could explain this discrepancy? A. The building automation system is malfunctioning, causing temperature swings. B. The outdoor air intake is contaminated or insufficiently filtered. C. The HVAC system is oversized relative to the building load. D. The duct system has excessive leakage causing loss of conditioned air. Answer. Correct answer. C. Explanation. An oversized HVAC system can short cycle and fail to properly condition and ventilate air, resulting in inadequate air changes and poor IAQ even if airflow specs C met while contaminated intake. B. Affects IAQ. It would likely be noted on inspection. Malfunctioning BASE affects temperature control but not directly IAQ. Duct leakage D impacts energy but less likely sole IAQ cause if volume meets design. Proper load sizing and ventilation balance are fundamental for maintaining IAQ. Question 4. When evaluating the merits of a proposed retrofit, Mr. Smith must decide between upgrading to a variable speed air handler or improving building envelope insulation in an older commercial building. What would be the best approach to maximize overall energy savings? A. Prioritize variable speed air handler to improve system efficiency and airflow control. B. Upgrade insulation to reduce thermal loads before equipment improvements. C. Replace both simultaneously to maximize short-term benefits. D. Install advanced controls on existing air handler to optimize operation. Answer. Correct answer. A. Explanation. Variable speed air handlers adjust airflow to match load dynamically, greatly improving efficiency and occupant comfort. Although upgrading insulation B reduces load, it may not provide immediate operational savings compared to system improvements. Simultaneous replacement C is costlier and less practical. Advanced controls D help but don't match the efficiency gains of variable speed hardware. Prior system-side upgrades can often yield more measurable savings initially per energy audit best practices. Question 5. Based on the information gathered during an audit, ISLU detects that the refrigerant system in a rooftop unit is operating outside the optimal pressure ranges, but the system's electrical consumption is within normal limits. What should ISLU conclude about the system's performance? A. The refrigerant charge is likely correct, but the compressor is failing. B. The refrigerant charge is incorrect, causing inefficient heat transfer despite normal power use. C. Electrical metering is unreliable and does not reflect actual load. D. The condenser fan motor is over-consuming electricity and masking issues. Answer. Correct answer. C. Explanation. Normal electrical consumption combined with abnormal refrigerant pressure suggests that electrical metering may be inaccurate or not reflecting load correctly. Incorrect refrigerant charge B usually causes increased power consumption due to compressor strain. Compressor failure A would change power draw. Condenser fan motor issues D would increase consumption but do not explain pressure anomalies alone. Accurate electrical and pressure diagnostics together are essential to understand true system condition. Question 6. As demonstrated by Mr. Thompson's audit, the psychrometric chart shows that during the summer, the return air entering the cooling coil has high enthalpy due to excess moisture. What energy conservation upgrade should Mr. Thompson recommend to address this issue? A. Install higher efficiency compressor to increase cooling capacity. B. Improve building envelope sealing to reduce infiltration of humid air. C. Add dedicated dehumidification system or energy recovery ventilator. D. Increase airflow volume across the coil to improve latent heat removal. Answer. Correct answer. B. Explanation. High return air enthalpy from moisture infiltration typically results from air leaks in the building envelope. Improving sealing reduces humid air infiltration, lowering latent loads and overall cooling energy. Adding dedicated dehumidification C is effective but more costly and secondary to eliminating infiltration sources. Higher capacity compressors, they do not address the root cause. Increasing airflow D might reduce coil efficiency and increase fan energy. Sealing aligns with building science principles for energy conservation. Question 7. Taking into account the complexities of data analysis in energy audits, Mr. Gomez notices utility bills fluctuating seasonally but no proportional changes in HVAC runtime logs. What conceptual explanation best fits this observation? A. The HVAC system has a variable load and runtime sensors are malfunctioning. B. Non-HVAC loads such as lighting or plug loads dominate energy use variations. C. The utility meter has been tampered with or misreading consumption. D. Building occupants are manually adjusting thermostats frequently. Answer. Correct answer. A. Explanation. Seasonal utility fluctuations with constant HVAC runtime suggest either load variability beyond runtime, such as changing cooling capacity or sensor malfunctions under reporting run hours. Non-HVAC loads. B. Typically vary less seasonally. Meter tampering. C. Is less common and usually ruled out early. Occupant thermostat changes D affect runtime but don't explain mismatched data trends. Sensor verification and load profiling are critical for accurate audit analysis. Question 8. With respect to HVAC safety protocols during an audit at a chemical manufacturing facility, Chen identifies refrigerant leaks near electrically energized equipment. What is the most appropriate immediate action she should take according to OSHA and industry safety standards? A. Continue the audit while documenting the leak for repair scheduling. B. Evacuate the area and notify facility safety officers to address hazards. C. Attempt to contain the leak using temporary seals before continuing inspection. D. Shut down all electrical equipment remotely to prevent ignition risk. Answer. Correct answer. D. Explanation. Refrigerant leaks near energized equipment pose fire and toxic exposure hazards. Shutting down electrical equipment remotely prevents ignition, aligning with OSHA electrical safety and refrigerant handling standards. Evacuation B is important but secondary to hazard elimination. Continuing inspection A. Risk safety. Temporary containment C is insufficient for immediate hazards. Prioritizing shut reduces risk and allows safe remediation. Question 9. Throughout the course of his audit, Mr. O'Connor finds that the building automation system's BAS sensor calibration is inconsistent, causing erratic HVAC control responses. How should HRConquer interpret this finding in relation to overall building energy efficiency? A. Sensor errors cause poor system feedback, leading to energy waste from overcooling or overheating. B. BAS sensor issues are minor and have limited impact on energy use if manual overrides are available. C. Calibration errors mostly affect occupant comfort, not energy consumption. D. Sensor recalibration should be deferred until after other equipment upgrades are implemented. Answer. Correct answer. A. Explanation. Inaccurate BAS sensors mislead control algorithms, causing inefficient operations such as overcooling or overheating, which directly increases energy use while occupant comfort is affected. Energy waste is a primary concern. Manual overrides B. may help but do not eliminate inefficiencies. Deferring recalibration D. prolongs energy losses. Proper BAS sensor maintenance is fundamental to efficient HVAC operation and audit recommendations. Question 10. From the perspective of equipment sizing, is Evans audits a recently installed chiller system that is running continuously without reaching set point temperatures during peak summer loads. What is the most likely cause of this issue? A. The chiller is undersized relative to the peak cooling load demand. B. The chilled water supply temperature sensor is miscalibrated. C. The building load has been reduced, causing control instability. D. The chiller condenser water flow rate is excessively high. Answer. Correct answer. C. Explanation. If the chiller runs continuously yet fails to reach set point, it often indicates either undersizing or control issues. However, if the building load has reduced e.g. due to envelope improvements, the chiller may short cycle or appear unable to reach set point because the system controls are not adjusted accordingly. Sensor miscalibration. B. Affects readings but not continuous operation. Excessive flow. D. Usually improves performance. Evaluating actual load versus design sizing is critical for accurate diagnosis. Question 11. While examining a commercial building's HVAC system, is Allen observed significant temperature stratification between floors despite well-maintained duct system? Which energy auditing principle best explains this phenomenon, and what should be the auditor's focus? A. Thermal buoyancy causing uneven air distribution. Focus on improving air balancing and return air paths. B. Refrigerant undercharge causing inadequate cooling capacity. Focus on recharging refrigerant. C. Excessive infiltration at upper floors. Focus on sealing building envelope leaks. D. Oversized equipment causing frequent cycling. Focus on equipment replacement. Answer. Correct answer. A. Explanation. Temperature stratification often results from thermal buoyancy effects causing uneven air distribution between floors. Proper air balancing and ensuring adequate return air paths can mitigate this. Refrigerant charge. B. Affects cooling but not stratification. Infiltration. C. Impacts low but stratification is a distribution issue. Oversized equipment. D. Relates to cycling but doesn't directly cause vertical temperature differences. Question 12. Given the circumstances of Mr. Edwards' energy audit of school with variable speed drives VSDs installed on HVAC fans, he notes unexpected energy consumption spikes during low load periods. What control strategy issue could be contributing to this anomaly? A. VSDs running at minimum speed without staging down equipment or disabling fans. B. Poor duct insulation causing heat gains and increased fan load. C. Incorrect refrigerant charge increasing compressor power draw. D. Thermostat set points too high causing fans to run longer. Answer. Correct answer. D. Explanation. High thermostat set points can cause fans to operate unnecessarily longer, increasing energy use despite ESD minimum speed. A. Might cause constant low energy use but not spikes. Poor duct insulation. B. Impacts thermal losses, not fan power directly. Refrigerant charge. C. Affects cooling equipment, not fan motors. Control strategies need alignment between set points and VSD operation for efficiency. Question 13. Through the lens of building science, Mrs. Carter inspects an office building's envelope and finds that moisture accumulation inside walls has caused insulation degradation, increasing heating loads. What principle should guide her energy conservation recommendations? A. Prioritize moisture control via vapor barriers and proper ventilation to maintain insulation effectiveness. B. Replace insulation with higher R-value material regardless of moisture issues. C. Increase heating system size to compensate for insulation loss. D. Add air sealing only around doors and windows, ignoring wall penetrations. Answer. Correct answer. C. Explanation. Increasing heating size. C. Addresses symptoms but not the root cause of moisture and insulation loss. Moisture control. A. Is the fundamental principle to preserve insulation and reduce heating loads sustainably. Replacing insulation without moisture solutions. B. Will fail long term. Partial air sealing. D. Neglects major infiltration paths through walls. Effective moisture management preserves energy efficiency. Question 14. When analyzing a commercial chiller plant, Mr. Nguyen notices that the chilled water return temperature is consistently above design, resulting in lower than expected cooling capacity. What is the most likely underlying cause, and what should be investigated first? A. Improper chilled water flow rates limiting heat absorption. Inspect pump operation and valve settings. B. Refrigerant leak in the chiller evaporator. Conduct refrigerant leak detection. C. Faulty BAS sensors reporting incorrect temperature readings. Calibrate sensors. D. Oversized condenser cooling tower. Verify condenser water flow and temperature. Answer. Correct answer. B. Explanation. A refrigerant leak causes reduced heat absorption and elevated return water temperatures due to diminished evaporator performance. Pump operation may affects flow but typically causes different symptoms. Sensor errors. C. Misreport but don't physically affect capacity. Oversized cooling towers. D. Generally improve condenser cooling, not reduce chilled water effectiveness. Question 15. Illustrated by Ista Wilson's data analysis from recent energy audit, the peak electrical demand occurs during early morning hours, contrary to expectations. Which operational strategy most likely explains this, and what should the auditor recommend? A. Nighttime equipment pre-cooling or preheating causing high demand. Recommend load shifting and scheduling optimization. B. Occupant behavior increasing early morning energy use. It suggests occupant education. C. Faulty demand meters causing erroneous readings. Recommend meter verification. D. Inefficient lighting systems activated during early hours. Advise lighting control upgrades. Answer. Correct answer. A. Explanation. Nighttime preconditioning loads shift peak demand to early morning, often raising energy costs and demand charges. Load shifting and optimized scheduling reduce peaks. Occupant behavior. B. Affects use but less likely causes early peak. Meter errors. C. Require confirmation but are less common. Lighting inefficiencies. D. Contribute to low but usually not peak demand. Timing shifts. Question 16. From the perspective of psychrometrics, Jackson identifies that indoor air has high relative humidity but low absolute humidity during an audit. What does this imply about indoor conditions, and what corrective action aligns best with energy-efficient operation? A. Low air temperature causing relative humidity to rise. It recommends slight temperature increase or enhanced ventilation. B. High moisture generation indoors. It suggests dehumidifier installation. C. Insufficient ventilation with outdoor air. Advise increasing fresh air intake. D. Leaking duct insulation, adding moisture. Recommend duct sealing. Answer. Correct answer. D. Explanation. High relative humidity with low absolute humidity suggests cool air causing moisture saturation locally, often due to duct leaks introducing moist air or condensation. Duct sealing. D. Reduces infiltration and moisture ingress. Moisture generation. B. Increases absolute humidity. Increasing ventilation. C. Can raise humidity unless outdoor air is dry, raising temperature. A. Affects RH but. Question 17. When faced with balancing energy conservation and occupant comfort in a high-rise office, Mr. Thompson must decide on ventilation rates. Considering ASHRAE standards and energy impacts, what strategy best addresses this challenge? A. Use demand control ventilation DCV based on code levels to optimize fresh air intake. B. Maximize ventilation rates continuously to ensure air quality. C. Minimize ventilation to reduce energy loads regardless of IAC. D. Implement fixed ventilation rates without occupancy sensors. Answer. Correct answer. B. Explanation. Maximizing ventilation constantly. B. Ensures air quality but increases energy use. Demand-controlled ventilation. A. Optimizes energy and I but requires reliable sensors and controls. Minimizing ventilation. C. Compromises occupant health. Fixed rates. D. Ignore occupancy variability. DCVA is industry best practice to balance energy and comfort, so it's preferred over B. B. Less optimal but correct. DCV is unavailable. Question 18. Considering the evidence from an audit of a refrigerated warehouse, Isa Patel observes excessive compressor cycling during peak load periods, leading to inefficient operation. What corrective measure aligns with HVAC system performance best practices? A. Install larger compressors to meet peak demand without cycling. B. Implement staging controls or variable capacity compressors to match load. C. Increase refrigerant charge to improve cooling capacity. D. Add supplemental cooling systems to reduce compressor runtime. Answer. Correct answer. C. Explanation. Increasing refrigerant charge. C. Can improve capacity and reduce cycling if the system is undercharged. Larger compressors A. May cause short cycling if not staged properly. Staging or variable capacity B. is the best long-term solution but may require significant retrofit costs. Supplemental cooling D. adds complexity and cost. Correct charge is critical for compressor efficiency and cycle control. Question 19. In light of recent developments in energy auditing tools, Mr. Lee uses thermal imaging and finds numerous cold spots on a building's exterior. How should Mr. Lee interpret these findings in the context of energy conservation? A. Cold spots indicate areas of heat loss due to poor insulation or air leakage. To recommend targeted ceiling and insulation upgrades. B. Cold spots suggest excessive shading, reducing solar heat gain. Advise removal of shading devices. C. Thermal imaging only shows surface temperature and is not useful for energy auditing. D. Cold spots indicate HVAC system malfunction. Suggest system recalibration. Answer. Correct answer. D. Explanation. Cold spots typically signify heat loss from poor insulation or air leaks, making A the correct interpretation. Excessive shading B reduces solar gain but usually doesn't create cold spots visible externally. Thermal imaging C is key auditing to HVAC malfunctions. D do not cause exterior cold spots. Thus, D is incorrect. Question 20. Throughout the process of performing a financial analysis for proposed HVAC upgrades, Green notices that the simple payback period is longer than industry benchmarks. What underlying factor should Green analyze further to provide a comprehensive recommendation? A. Initial equipment cost versus lifecycle energy savings. B. Current utility rate structure and demand charge components. C. Equipment maintenance costs and downtime impacts. D. All of the above. Answer. Correct answer. B. Explanation. Utility rate structures and demand charges significantly affect payback calculations, often overlooked but critical for accuracy. Initial cost to maintenance and C. matter but don't solely explain long paybacks. Full analysis D is ideal, but B targets common key factor impacting financial viability, especially in commercial audits. Question 21. In a modern context of energy auditing, Mr. Davis is reviewing a multi-zone HVAC system showing uneven humidity control across zones despite similar cooling loads. What is the most likely cause, and what should Mr. Davis focus on during his diagnostic approach? A. Faulty zone dampers causing improper airflow distribution. Focus on damper calibration and actuator function. B. Refrigerant overcharge reducing core performance. You verify refrigerant charge and pressures. C. Inaccurate temperature sensors affecting thermostat readings. Recalibrate all sensors. D. Insufficient building envelope insulation causing localized humidity gains. Assess wall and window assemblies. Answer. Correct answer. C. Explanation. Inconsistent humidity control often stems from inaccurate sensors causing improper thermostat responses, leading to zone imbalances. Faulty dampers A. cause airflow issues but less humidity variation. Refrigerant overcharge B. affects cooling capacity but not specifically humidity. Envelope insulation D. affects overall loads but less likely causes zone humidity inconsistency. Accurate sensor calibration is critical for effective control. Question 22. With the advent of new diagnostic tools, is Johnson uses a manometer during an energy audit of a commercial HVAC system to measure static pressure in ductwork. Why is this measurement essential, and what should Johnson infer if static pressure readings are significantly higher than design? A. High static pressure indicates duct leakage. Recommend duct sealing. B. Elevated static pressure suggests undersized ductwork or dirty filters restricting airflow. Recommend system cleaning or resizing. C. High static pressure means insufficient blower speed. Increase fan RPM. D. Low static pressure indicates excessive airflow. Reduce fan speed. Answer. Correct answer. B. Explanation. High static pressure typically signals airflow restriction from undersized ducts or dirty filters, which reduces system efficiency and comfort. Duct leakage usually causes low static pressure, increasing fan RPM. C. Might exacerbate pressure issues. Low static pressure. D. Is a separate condition. Measuring static pressure helps identify airflow impediments, a key step in diagnosing system performance. Question 23. Taking into account the fundamental principle of refrigeration cycles, Mr. Walker is auditing a system with a flooded evaporator that causes liquid refrigerant slugging in the compressor. What is the primary cause and recommended corrective action? A. Low evaporator superheat. DSV to increase superheat and prevent liquid return. B. High condenser pressure. Clean condenser coils. C. Improper refrigerant charge. Add a refrigerant. D. Fault compressor motor. Replace motor. Answer. Correct answer. A. Explanation. Flooded evaporators and liquid slugging result from low superheat, allowing liquid refrigerant to enter the compressor, risking damage. Adjusting the TXV to increase superheat is the correct corrective action. High condenser pressure. B. And refrigerant charge. C. Affect system performance but are not the direct cause here. Compressor motor faults. D. Don't cause liquid slugging. Question 24. From a practical standpoint, Morales is analyzing utility bills for a large office complex with multiple HVAC systems. She notices irregular spikes during weekends when occupancy is low. What is the most plausible explanation and recommended next step? A. Systems are operating on fixed schedules without weekend setbacks. It recommend implementing advanced scheduling controls. B. Unexpected occupant activity increasing loads. It suggests occupant education. C. Faulty utility meters causing billing errors. It recommends utility verification. D. HVAC equipment is oversized and cycling inefficiently. It suggests equipment replacement. Answer. Correct answer. B. Explanation. Unexpected occupant activity on weekends can increase loads despite low scheduled occupancy. Educating occupants may help reduce energy use. Fixed schedules usually cause continuous loads, not spikes. Meter faults. C. Need ruling out but are less common. Oversized equipment. D. Causes inefficiency but wouldn't explain weekend spikes alone. Question 25. Considering the evidence gathered during an energy audit, Singh finds that infiltration air leakage around windows is causing high latent loads, increasing cooling energy use. What energy conservation measure best addresses this? A. Upgrade HVAC equipment to higher efficiency models. B. Apply weather stripping and sealant around window frames to reduce air leakage. C. Increase outdoor air ventilation to dilute humidity. D. Install larger cooling coils to manage latent loads. Answer. Correct answer. B. Explanation. Sealing around windows with weather stripping reduces air infiltration and latent load, directly addressing the root cause. Upgrading equipment. A. Addresses symptoms, not causes. Increasing ventilation. C. Can add humidity rather than reduce it. Larger coils. D. Increase capacity but are less energy efficient than sealing leaks. Question 26. In the absence of comprehensive building plans, Kim must estimate heating and cooling loads using on-site measurements. Which energy auditing tool or method best supports this effort for accurate load estimation? A. Using a blower door test combined with thermal imaging to assess envelope tightness and insulation. B. Measuring refrigerant pressures to determine HVAC capacity. C. Reviewing utility bills to infer energy use patterns. D. Surveying occupant comfort complaints. Answer. Correct answer. A. Explanation. Blower door testing combined with thermal imaging provides direct data on building envelope tightness and insulation quality, crucial for load estimation without plans. Refrigerant pressures, B. Relate to HVAC, not loads. Utility bills, C. Show energy use but not load specifics. Occupant complaints, D. Are subjective and not quantitative. Question 27. When evaluating HVAC system performances, Alvarez notices that the supply air temperature is consistently higher than the set point during cooling. What is the most likely control system issue, and what should be verified first? A. Malfunction in cooling coil valve stuck partially closed. Inspect valve operation and actuator. B. Incorrect thermostat set point. Verify user settings. C. Dirty air filters causing reduced airflow. Replace filters. D. Faulty condenser fan motor. Check motor and controls. Answer. Correct answer, D. Explanation. A faulty condenser fan motor reduces heat rejection, causing elevated supply air temperatures. Cooling coil valves, A. Primarily affect chilled water flow, not supply air temp directly. Thermostat settings, B. Affect demand, but not supply air temperature. Dirty filters, C. Reduce airflow, lowering cooling capacity but less likely raise supply air temp beyond set point. Question 20. From the perspective of refrigerant management, Mr. Bennett is auditing a facility with an aging R22 system showing gradual pressure drops and increased runtime. What is the best energy auditor practice to ensure system performance and environmental compliance? A. Recommend immediate refrigerant replacement with a modern refrigerant and system retrofit. B. Perform leak detection and charge adjustment to optimize current system performance. C. Ignore pressure drops if compressor amperage is normal. D. Advise system shutdown until complete replacement is feasible. Answer. Correct answer, A. Explanation. Replacing outdated R22 systems with modern refrigerants and equipment ensures environmental compliance and improved efficiency. Leak detection and charging. B. Provide temporary relief but do not address phase-out regulations. Ignoring pressure drops. C. Risks damage. Shutdown. D. Is impractical for most commercial facilities. Question 29. Throughout the course of an audit, O'Neill identifies that air distribution system leakage is causing uneven airflow and increased fan energy consumption. What building science principle supports the most effective remedial action? A. Seal all duct leaks and insulate ducts in unconditioned spaces to reduce pressure losses and heat transfer. B. Increase fan speed to compensate for leakage. C. Replace ducts with larger diameter to reduce velocity losses. D. Add supply diffusers to improve airflow distribution. Answer. Correct answer, C. Explanation. Increasing duct size reduces airflow velocity and pressure losses, but this is expensive and less effective than sealing leaks. Sealing and insulation is the best practice to reduce losses and energy waste. Increasing fan speed, B. Wastes energy and worsens leakage. Adding diffusers, D. Improves distribution but doesn't fix leakage. Question 30. To what extent does improper thermostat placement affect HVAC energy auditing results as observed by Mr. Garcia during a residential audit? A. Thermostats placed near heat sources or direct sunlight cause inaccurate temperature readings leading to inefficient HVAC cycling. B. Thermostat location has minimal effect if system has variable speed controls. C. Improper placement only affects occupant comfort, not energy use. D. Relocating thermostats is costly and rarely justified in audits. Answer. Correct answer, B. Explanation. Thermostats near heat sources or sunlight skew temperature readings, causing inefficient cycling and energy waste. Variable speed controls, B. Can partly compensate but do not eliminate errors. Placement affects both comfort and energy, so C is incorrect. Relocation costs vary but are often justified by energy savings, so D is misleading.